Writers, filmmakers, and artists have often attempted to envision the future. The 1968 movie 2001: A Space Odyssey was a bit too optimistic about our space program. Pan American Airlines never did make it into space. And if you're like me, you've probably often wondered to yourself, it's the 21st century, where's my jetpack? Making predictions is hard, especially about the future. That's one reason climate deniers often say that science has no ability to predict the consequences of future changes in a greenhouse world.
I think all you scientists are crackpots. Nothing is going to happen.
It's true that climate science uses models to test hypotheses about climate change. We don't have another planet to experiment on or hundreds of years to observe changes. So we have to do as best we can with mathematical models, taking into account as many factors as we can. One important difference between climate models and science fiction is that models incorporate the actual physical properties of greenhouse gases and the laws of gravity, physics, and thermodynamics. This clip from Ian Stewart's brilliant documentary, Climate Wars, illustrates one of the known properties of CO2.
I can show you how carbon dioxide affects Earth's climate using this heat-sensitive or infrared camera which is purring away here, and a candle, this glass tube which is hooked up to this rather large canister of carbon dioxide gas. Now if I light the candle, you'll see that on the monitor the camera picks up the flame perfectly. Look at that. The hottest parts are glowing white. Now watch what happens when I turn on the carbon dioxide.
Just keep your eye on the flame.
The gas is invisible, so you don't see it fill in the tube. But as it comes in, you should see the candle start to disappear. There it goes. Look at that. What's happening is that the carbon dioxide in the tube is effectively trapping the heat.
The candle's warmth no longer reaches the camera. Instead, it's absorbed by the carbon dioxide inside the tube.
Climate modelers incorporate actual physical and thermodynamic laws into their increasingly sophisticated models. One of the world's centers of climate modeling is the Goddard Institute for Space Studies in New York. It was here in the 1970s that a young scientist, James Hansen, began asking questions about the effects that human activities were having on the atmosphere. A student of physicist James Van Allen, Hansen had done his doctoral studies on the atmosphere of Venus. Venus is a primary example of the effects of greenhouse gases.
Venus is closest to Earth in size, mass, and gravity, but it has a dense atmosphere of carbon dioxide, and there is almost no water. The surface of Venus is extremely hot, with an average temperature of over 800 degrees Fahrenheit.
In modeling climate on Earth, Hansen's team had an imperfect set of temperature data to work with. To compensate, they simulated the motion of large air masses, which often cause similar effects on weather stations hundreds of miles apart. In 1978, Hansen chose to input climate data from a known event in the past to see if the model would recreate or hindcast the results. The eruption of Mount Agung in Bali in the 1960s had been well studied. Large volcanic eruptions eject huge amounts of dust into the atmosphere that reflects sunlight and can cool temperatures over a whole planet for a year or more. The study concluded that the magnitude, sign, and time delay of the temperature changes are in excellent agreement with those of the changes observed after the eruption of Mount Agung. It was a confidence builder for the young scientist. In 1981, he was back with a new study, this time not a hindcast, but a bold forecast of greenhouse effects a century into the future. The paper was remarkably prescient. Hansen wrote, "It is shown that the anthropogenic carbon dioxide warming should emerge from the noise level of the natural climate variability by the end of the century, and there is a high probability of warming in the 1980s. The report predicted a larger sensitivity at high latitudes, which has now actually been observed. In addition, Hansen's model predicted the erosion of the West Antarctic ice sheet, which is now underway, and the opening of the fabled Northwest Passage through Arctic ice, which actually occurred in 2007. Hansen's message was clear. The time to act had come. Unprecedented change was imminent. But it was the 1980s, and the country was unwilling to hear the message. We were told that trees cause pollution, that real men drove for oil, and government expenditures on non-fossil fuel energy, which had soared after the 70s oil crisis, dropped dramatically. The nation slept for 7 more years, and Hansen continued to refine his methods. In 1988, he was ready to sound an even more urgent warning.
Altogether, this evidence represents a very strong case, in my opinion, that the greenhouse effect has been detected and it is changing our climate now.
In dramatic testimony before Congress, Hansen presented 3 scenarios. Scenario A, a very high emission scenario, showed dramatic warming through the coming 21st century. Scenario B, considered the most plausible, showed a slower rise in emissions and temperatures. Scenario C assumed a rapid drop in carbon emissions and showed a slower rise and an earlier plateau in temperatures in coming years. Over the last 2 decades, actual temperature measurements have tracked closely with Hansen's Scenario B. But what is most interesting about the prediction is that Hansen built in a mechanism to check the assumptions in the model. Scenario B included a hypothetical large volcanic eruption in the mid-90s and modeled the global atmospheric response. Hansen gambled that such an event would prove or disprove the accuracy of his science. He didn't have long to wait for an answer. In June of 1991, Mount Pinatubo in the Philippines blew up in the most powerful eruption since 1912, ejecting huge amounts of reflective material into the atmosphere, similar to the Mount Agung event in the 60s, only larger. Over the following year, global temperature measurements showed a dip, a notch in the record almost identical to the one predicted in Hansen's model. It was a resounding affirmation of the predictive skill of Hansen's methods. Since 1988, the Intergovernmental Panel on Climate Change has periodically published continuing work and refinements on climate models. With each new iteration, climate modelers are able to slice their data ever more finely. The collected predictions of the last 20 years can now be evaluated. The first assessment in 1990, the second assessment in 1995, and the third in 2001 can now be compared to 20 years of actual data, and the results are impressive. In the most recent fourth assessment report, AR4, researchers collected results from 58 forecasting and hindcasting model runs from 14 different climate modeling groups. We can see the results are consistent and tightly grouped, and there is a close correlation between the average of all the model runs and the actual observed global temperatures. Also, over the last century, the models were successful in simulating the results of the largest volcanic eruptions. Climate science is not completely dependent on climate models. There are many threads of supporting evidence. Still, it is clear that climate models are telling us something that is important and we cannot afford to ignore. This is a huge topic and I've run out of time. I'll be returning to this subject in future videos, so keep sending me questions and challenges, and I'll do my best to address them all in upcoming Climate Denial Crocs of the Week.